We're in section 1.6. Let's work a couple more examples of rational equations. So we have a new equation here to solve, and remember the first thing we want to do is identify the domain of the equation. And so it might be helpful if you recognize that the denominator here on the right is exactly the same as x times x plus 1. So if we can factor that denominator, then we recognize that those are the same factors that we already have over here on the left. And so then for the domain, we can say if x plus 1 is not equal to 0, then x is not equal to -1. And then in the next fraction, the denominator is just x. So x cannot be equal to 0. So that's the restriction on the domain. And then we want to make sure we identify the LCD. And so we have a factor of x plus 1 from the first fraction, and we have a factor of x from the second fraction, and then we have those same two factors again. So they're already accounted for here in our LCD, so we don't need to do anything else for that. We just need to multiply both sides of the equation by x times x plus 1. And I'll write it over here on the right side as well. Okay, and so then when we multiply x times x plus 1 times the first term on the left, can you see that the x plus 1's will cancel? And we're just left with x times 4x plus 3. And then when you multiply x times x plus 1 times the next term, the x's cancel, and we're left with 2 times x plus 1. And then on the other side, both factors, x and x plus 1, cancel, and we're just left with 1. So we cleared out the fractions, we multiplied through by the least common denominator, and we wound up with this equation here, which we recognize as a quadratic equation. So we already know how to solve that. We already studied that in a previous section. So really the new material here in this section are the two steps that we've just done, to identify the domain and then to multiply through by the least common denominator. Those are the two new things that we need to know to solve a rational equation. Okay, let's go ahead and solve this quadratic. Let's distribute the x and get 4x squared plus 3x. Let's distribute the 2, get 2x plus 2, and then all that's equal to 1. And then for a quadratic, usually we want to set it equal to 0, and then we can either factor it or we can use the quadratic formula. So if we subtract 1 from both sides and we combine the 3x and the 2x, then we'll wind up with 4x squared plus 5x plus 1 is equal to 0. And so if you're going to factor this, notice that the coefficient on the x squared is not 1. And so that's a special kind of factoring called factor by grouping. In order to start that, we need to find two numbers that multiply to the product of this leading coefficient and this constant. 4 times 1 is 4. So find two numbers that multiply to 4 and also add up to 5. And we can see pretty quickly that that would be 1 and 4. And so remember how we do this now. We're going to rewrite the middle term as the sum of 1x plus 4x. 1x plus 4x for that middle term. And then the leading term just comes along and the constant, and so on. So that's the first part of factor by grouping. And then the next part is to go ahead and factor just out of these first two terms. There's a common factor of x, and then that would leave 4x plus 1 left over. And then in the next two terms, there is no common factor, or another way to say that would be to say the common factor is just 1. And so we're left with 4x plus 1. And that looks real good because now when we look at this large term and this large term, they have a common factor of 4x plus 1. So we can factor it out. And we get 4x plus 1 times what's left over is an x plus 1. All that's equal to 0. So we've got it factored. We could multiply these two factors back out to verify that that really is equivalent to this trinomial that we started with. Then to continue on with the problem, we take each factor and set it equal to 0. And then you'd have 4x is equal to -1 and x is equal to -1/4. Or you'd have x plus 1 equals 0 and x equals -1. So we have two answers. Remember, we have to go back and check that they're both in the domain. -1 is not in the domain, so we're going to have to throw this one out and say not possible. And then the -1/4 is okay. It is in the domain, and it is the only solution. Okay, let's do one more. Maybe you've got the hang of it, and you'd like to try to work this one for yourself before we go together. The domain will be x is not equal to 1. Because if x is equal to 1, then the denominator is 0. Same for this denominator over here. And then the LCD is just x minus 1. And so when we multiply 3x squared over x minus 1 times x minus 1, the x minus 1's cancel, and we're just left with 3x squared. And then when we multiply 2 times x minus 1, that's what we get. And then on the right-hand side, the x minus 1's cancel, and we're just left with x. Okay, well, we've got a quadratic. We know how to solve quadratics. Let's go ahead and get on through this. Let's go ahead and distribute the 2 and then subtract the x from both sides. And then 3x squared plus x minus 2 is equal to 0. Once again, the coefficient on the x squared is not 1, so you would need factor by grouping. You can also do it mentally, and you might have seen this in a previous course. In this case, there aren't very many combinations to consider. If you're going to have 3x squared, then 3 must be 3 times 1. And then if you're going to have the last two terms multiply to -2, then that's a 2 and a 1. And if we're real careful, if we put the 2 over here and the 1 over here, and a plus sign here and a minus sign here, then I think that'll work. When I do it as fast like that, I always want to go back and double check. So 3x squared and then plus 3x minus 2x is plus x. Minus 2 times 1 gives me the -2. So that worked out okay. And so now I can go ahead and set each factor equal to 0. If I add 2 and divide by 3, I get x equals 2/3. If I subtract 1 over here on the next equation, I get x equals -1. I believe both of those answers are in the domain, right? The domain says x is not +1. -1 is okay, 2/3 is okay. This equation has two solutions. You could check them both by plugging into the original equation. Okay, that's all for the rational equations. We'll go on and look at a radical equation in the next example.